How's everyone doing? All right then. So I'm going to talk a little bit about what it's Beam and what we mean by portability. Here's the agenda. It's going to be a quick introduction to Beam. Then what we mean by portability, why we at Google invest and care about Beam. Then I'll show you what the Flink plus Beam integration looks like. And I'll also talk a little bit about the rough edges of running pipelines on Flink. And I'll tell you also a little bit about the things that we're doing on the testing environment. And if you're interested, I'll also tell you how to get involved. So anyway, if you're at this conference, you at some point realized that you had some stream or some set of data, and you wanted to apply some computation, and you probably had a bunch of data or a good amount, so that you wanted to apply the computation on multiple machines, right? And you probably looked at a distributed kind of computation so some sort of distributed framework, distributed runner. And so as you were thinking about this, you wondered probably what framework what runner should I use to do this computation? And here I am to suggest you the n+1 option that you can consider, which is Apache Beam. It was open sourced by Google around 2000, I think it was 16. What Beam is a portable and unified programming model for batch and streaming. And the keywords are portable and unified. And so what we mean by unified is that we have the same API for batch and streaming computations. So maybe if you write your pipeline and you have it running every night to perform some aggregations or some computation, and eventually you say, I want to get better latency on this. I want to have some real-time, alerts or whatever. You can take that pipeline and add a few lines of code to tell the runner how to deal with the streaming semantics, and you can run your pipeline in streaming without any large changes because we have the same API. So that's what we mean by unified. What do we mean by portable? Ideally, you should be able to write your pipeline in Beam and have write on any runner and write it on any language of your choice. Yes. As of today, we have some portability on these runners and some portability on these languages. So Beam does have a Java, Python, and a Go SDK, and there are runners for Flink, for Hadoop, Spark, and Dataflow. Dataflow is the Google Cloud batch and streaming engine. And so, colors are not good. But anyway, so what does that look like? So ideally, you should write your transform in the language that you want. So this is what a sum per key looks like in Java for Beam. This is what it looks like in Python. It's a little bit of a quirky API, but we also have a Go SDK, and more recently, a bunch of runners came up with a SQL, with support for SQL, which is usually built on top of Java. And so ideally, you can write your pipeline in any language of your choice, and you can run it in these runners. And so we arrived at this idea, when we were thinking about Beam, we were trying to find some abstractions for, initially it was abstracting how we deal with the business logic and the streaming semantics, right? And gladly that helped to design a single API that handled both. But we also looked at how we can abstract the user functions from the runner semantics, so that we could build a portable runner, which is also, the runner would be in charge of the execution of the DAG, of the graph that you build, and the Beam SDK, Beam developers, we call it the SDK, would be in charge of running your functions, right? And so we, as we designed Beam, the ideas of the design helped us arrive at some interesting abstractions. So what does it look like today? Today, you can write a Java pipeline and more or less run it well on all of these runners. And that's in terms of runner portability. But how about the Python and the Go SDK? So in terms of what we call language portability, we currently have an MVP where you can write your pipeline on any of these 3 languages, and you can run it on Dataflow or on Flink. So we have a decent support for all these 3 languages on those 2 runners. All right, yes, and so now the thing by language portability, and when I say, oh, you should be able to write your pipeline in any language that you need, is it doesn't mean that we get all languages for free, but it kind of means that we're trying to lower the barrier for implementing a new SDK. And so, as an example, when we were writing Beam, the Java SDK came from an internal framework at Google that had been out for years. Whereas the Go SDK, which is the latest, was built pretty quickly because it was built on top of these abstractions, which is part of abstracting the execution of the DAG and the business logic. So on the one hand, we designed an API for pipeline construction and job submission, and there's also an API for we call them fun runners, and they're fun because they run the user functions, and so they're we have an API for job submission and an API for exchange of data and control for the for the user-defined functions. And so then you might wonder, why do you guys at Google develop this open source thing if you have your cloud service? And so I think the reason that we invest in this is, on the one hand, I think it helps us make Cloud Dataflow, which is the managed service for batch and streaming at Google, it helps us make it a better product and kind of meet our customers where they are. So if perhaps you have some sensitive data that you don't feel comfortable moving to the cloud, and you want to have a deployment on-prem, or you run on another cloud, and you have your Flink cluster or whatever, you can ideally write your pipeline in Beam and run it there, right? That's one reason. Another reason is that we're also a bunch of engineers, and I personally am thrilled to work on open source, and I think we enjoy all of the collaborations that there have been between open source communities. These are some things that have come out of collaboration between the communities. The very cool one is, or one that I really like, is Streaming SQL, which came out of a very long thread between the Flink and Beam and Calcite mailing lists. So today, Beam and Flink implement Streaming SQL through Calcite, and it was a lot of fun for all of the engineers that participated, and I think we're very happy participating in these communities. Also, there's some investments in Beam from Google where the TensorFlow team writes a bunch of utilities for TensorFlow Extended, which are written in Beam. So ideally, if you have some data cleaning or some data scaling or any transformations that you apply to your data before you send them to a machine learning model, you can use TensorFlow Extended, and your TensorFlow Extended pipeline should be able to run in Dataflow, Flink, and other runners that may come. This thing is the logo for Flume, which is the internal data analytics service at Google that internal teams use. And so now the Go, Python, and Java SDKs for Beam, they're the standard SDK that teams are encouraged to use to write pipelines. They don't run on the external Google Cloud service, but they do run on an internal service that implements similar abstractions and that uses Beam basically. And so, there was this pretty picture of what Beam looks like today. We have Java, Python, Go. There's this portability layer, which, by the way, uses gRPC. So this also means that for any language that we want to support, there has to be decent support for gRPC on this language. And yes, so currently there's these runners that are, have pretty good support. The local direct runner, we call it, and the data flow and Flink runners. So yes, I was encouraged to show you some Go code. So this is our our Go word count pipeline. So you can take this pipeline today and as you can see, it's Go code, and we read lines in from some files, and we apply a count transformation. Then we apply a formatting. We call it Pardue. In Flink, it's a map. And so we apply some formatting, and then we write it to files. And so this is a pipeline written in Go that we have currently running continuously on Flink for our tests. And so this all looks very nice, but there are on the portable runner for Beam on Flink, there are some rough edges. So when we say this nice portability layer API involves a lot of things. So there's one thing, it's executor setup, right? So when you have your workers, you need to tell them how to set up in Beam we do it with Docker containers, but how to set up any runtime for Python or for Go. You need to, if you have your user-defined functions, you want to log what's going on within them. So we also have to define a logging API state because you have Beam and you want to operate on state. Lyft was just now speaking about how they really needed state. So we also needed to have an API that allows to connect the Beam state API to the Flink state API, retrieving artifacts, so getting the Python executables or the Beam jars, or Go. For Go, we do a large static binary. So that's one thing. There's also job submission. So if you have a pipeline that you wrote in Go, how do you convert that pipeline into something that Flink understands? Because Flink understands Java, right? And so this is this is the Facebook picture, and this is like the actual picture of what it looks like. and so over here you have your Flink cluster, and to set up the runtime for Python or for Go, we use Docker containers, right? And we don't have to use Docker containers. At Lyft, they don't use Docker containers. They simply use a Python process on the side. And so something else that you have to do is you have to stand up a job server and an artifact staging service. So this job server is what actually knows how to take a Beam pipeline, which is it's in protobufs, which is an interchangeable format, and convert that into a Flink pipeline, and then submit that Flink pipeline to the actual Flink cluster. So it's it is not a trivial integration. It is a bit of a complex system integration, but thankfully we have we have been able to have a decent API defined here and a decent API defined between the executor and the runtime, so that it's kind of, again, lowering the barrier for new SDKs and new runners. Right? And so what are the rough edges? A lot of the rough edges are also for operations, right? So you do have to stand up the new services. There's also data sources. So currently, the integration doesn't integrate with the source API of Flink and the source API of other runners. So you have to have some tricks to be able to split the computation at large scale. In Lyft, what they do is they insert a Flink Kafka source, which is written in Java. So they take a Beam pipeline, and they say, oh, we're going to add a Kafka source to the beginning of this pipeline. Deployment, as I was saying, it's a little awkward. And very large scale. So we have a staff engineer whose job is to get very large TensorFlow extended pipelines to run on, on batch on Flink. We're at a few gigabytes now, where we'll send in all this data, and we'll see that the the workers start running out of memory or running into trouble. So we're working on scaling up a batch pipeline, which really kind of hammers the runner, right? Yeah, and so something cool and something that came up of this abstractions between user-defined functions and DAG execution is that we're experimenting with multi-language pipelines. So today we have, let me see, we have it here. Okay, it's not very well visible, but we have a Python pipeline where we read some lines, and then we do some formatting of the lines. Later we write them to files, and here this thing is called external transform. And so this external transform calls out to a service that provides a Java transform. And it's not useful for counting words, but it is useful for providing reading from Kafka, reading from Kinesis, reading from lots of diverse data sources that have support on Java and don't have support on Python. So this is the bleeding edge. This is we recently started running this on Jenkins every few hours. Yes. So ideally, we'll get this to work in a number of months. But it is a bit of an exciting thing. Anyway, so features in the roadmap is we want to work on connectors. So we want to finalize the parallel source API, and multi-language pipelines. That's also pretty cool. And yeah, if you're interested in trying it out, you can clone our repository. You can look at. I'll share this slides, but you can look at how to run a pipeline on Flink. You can try TensorFlow extended. It has pretty good performance locally, and you can also run it on Flink and Dataflow. And if you're interested to learn further, the main thing I would recommend is the Apache Foundation Slack. I am always there, and a bunch of us are there often. And we also have mailing lists that you can subscribe. We have a Twitter handle and a YouTube channel. Yeah, and that's it. I thank you very much. Yeah. Questions now.
Yeah, I think we have time for one or two questions.
Can you use Beam with any version of Flink, or are you tied to a specific version of Flink? And how do you keep Beam in sync with Flink if it's an abstraction on top of Flink?
Yeah, so I think specific versions of Beam are tested with specific versions of Flink. So I think the latest release of Beam was 2.11, and I think that's tied to 1.7 of Flink. Yeah.
Any more questions?
So in general, what is the lag between Beam and new functionality that comes in Flink? Like, for example, the full transactionality that we saw. Is that something that's expressed fairly quickly? Or?
Yeah, I think this full transactionality I think was kept as Verbetica proprietary. So we're trying to learn how they did that, but. I think we're not specifically tracking Flink, so if there's a cool feature, we'll try to implement it, and we'll also try to add our own features. So I couldn't tell you. I can tell you, for instance, SQL. Flink and Beam got SQL around the same time, but I guess we're not following Flink the whole time.
Thank you. Is there support for additional connectors via this pipeline, or do we have to depend on Flink connectors?
So there is some connectors. So there's reading from files, either GCS, S3, etc. There aren't many connectors, and yes, so currently you would have to use Flink connectors. Ideally, once we have this multi-language pipelines, you should be able to use the Beam connectors. But that's still, really, a few days ago we got the test to run, so that's still going to take a while. So just a couple connectors currently.
Okay.
Hi. So you use containers, Docker containers, to execute Python code, right?
Yes.
And how good is the support for like state management, like sending state to and from the container?
There's. So we partnered with Lyft to have a full Flink runner, and they really needed state. So currently state works well in Flink, and it works better than in Dataflow, and which is But so yes, Flink state works all right. It works fine.
All right. Thank you again.
Thank you.